Let's use mathematical induction to prove the given statement. Let's prove that it is true for all positive integers k. Now remember, in mathematical induction, there are multiple procedures. You want to first show that the first proposition is true. Then you want to suppose that the kth proposition is true for a particular k, or you can even envision it as a fixed k. And then you want to show the very next step is true. In other words, the kth plus 1 proposition is true. That way it causes a domino effect, and then we could actually conclude that it is true for all positive integers k. What's confusing is, what is proposition of 1 and what is proposition of 2? What is proposition of 3? So why don't we look at proposition of 2? And we want to see if this is actually true. So this is not going to be part of the proof, but I'm going to just clarify things by examining proposition 2. Let's examine 6/7 plus 6/49. And let's see what this really is. So let's find a common denominator. The common denominator is 49. And notice we get 48 over 49. But what is 48 over 49? Isn't that just 49 over 49 minus 1 over 49? And that's 1 minus 1 over what? 7 squared. And that is equal to what? 1 minus 1/7 squared. So looking back at this, we started with 6/7 plus 6/49. Notice we have shown that the left-hand side of the proposition is in fact equal to the right-hand side of the proposition. This is also known as proving an identity. What can we say now? We could say, therefore, proposition 2 is true. So you could try to figure out what proposition 3 is. However, in the principle of mathematical induction, we only need to show proposition 1. So why don't we observe proposition 1? We'll start with 6/7. We start with 6/7, and we want to know what that looks like. Well, that looks like 7 over 7 minus 1 over 7, which is equal to 1 minus 1 over 7 raised to the first power. Well, did we show that proposition 1 is really true? Yes, we did. Therefore, proposition 1 is true. Now we're going to suppose that piece of k is true. Suppose p sub k is true. What does that mean? We're going to say 6/7 the kth proposition is true. Okay, we're going to draw 3 dots now. Plus 6/7k, 7 to the k, is equal to 1 minus 1/7 raised to the k for, let's say, a fixed k value. Now, our goal is to show that p sub k plus 1 is true. So let's observe p sub k plus 1 on the left-hand side of the equation. And our goal is to observe this. So we started half of the proposition of k plus 1 right now. So what do we want to show? We want to show that the right-hand side of the p sub k plus 1 proposition is actually going to get what? It's actually we want to work our way to equal 1 minus 1/7 raised to the k plus 1. This is our goal. Okay, so far we only have the left-hand side of the proposition, and so we're going to work our way towards that. Well, how do we do that? We're going to use our hypothesis that we stated in the previous step. What was our hypothesis again? There it is. So we're going to substitute that. This is now equal to 1 minus 1/7 raised to the k power. And we still have what? Plus 6/7 raised to the k plus 1. Now, obviously, we need some common denominators. Why don't we keep this 1 though? And let's get a common denominator here. So minus 1 to the k over 7 to the k times what? I need a 7/7. And then we still have plus 6/7 to the k plus 1. Let's keep observing this. We have 1 minus 7 and then plus 6/7 to the k plus 1. If we collect like terms, we now have 1 minus a 1/7 to the k plus 1. Because -7 plus 6 is -1. Is that what we want to show? Almost. We almost got there. One more step. Equals 1 minus 1/7, all parentheses, to the k plus 1 power. That's it. That's what we wanted to show. Let's see, what have you just shown? You have shown that this is equal to that. So I'm just going to restate that. Therefore, 6/7 plus 6 over 49 plus dot 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 plus 6 over 7 to the k plus 6 over 7 to the k plus 1 is now equal to 1 minus the quantity 1/7 raised to the k plus 1 power. Well, since we could actually get the next domino to fall over, we could actually draw our conclusion now. Therefore, 6/7 plus 6 over 49 plus dot 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 plus 6 over 7 raised to the k is equal to 1 minus 1/7 raised to the k. And the biggest difference now is that we want to emphasize for all positive integers k. And there we go. That ends the proof. So be careful when you're trying to circle your answer here. When you circle your answer, you're going to have to circle your entire proof. So let's try that. Circle our proof, and then we come back down. And there we go. And remember not to skip any steps. So that is a solution